In this application, we are looking at the end of a small metal tube that's about 3 millimeters by 3 millimeters. And in this case, we used a single point white light confocal probe, the CL1, with an MG210 magnifier. And we use this because it has a very good lateral resolution of better than a micron. And what we did is we went 3 millimeters and we took a data point every micron and dropped the scan down a micron and took another one. So we took a lot of data just to get as much information as we could on this target. And here you can see the target that we're measuring. And to give you a quick view of it, let's take a look at the 3D view. And you can see pretty well that we're getting a very good representation to where we can see the surface roughness even on the part. And it is a little skewed where the surface roughness is showing is not at the same dimension as the diameter. So we're actually accentuating the surface roughness of this part. So let's go back and see if we can measure that diameter. And one of the first ways we're going to do is we're going to take a profile across it. We're going to go west to east, and we're going to do this right across the middle. And you can see that as we bisect this center, we're getting the two different inner diameters of that part. So let's take a look at that. We'll put it in absolutes. And we're going to come in and we're going to do it. This is just a rough measurement to show you that this is pretty much how it would be done, where we would take this point so from outer edge to outer edge, we're showing 2.66 millimeters, and if we wanted to look at that ID, the ID is about 1.56 millimeters. We're showing a height difference there of about 2 microns. So what this does just manually show how we would go about getting that diameter of that part, which would be through software to do the same sort of function where we'd come through and we would bisect this part and we'd take that measurements. We also can take a look at the surface roughness of that surface area on the top. And here you can see with the click of the button, we've got ISO 25178. Here's your S of A numbers. It's about 26 microns over that total area for roughness. If we want to, we could also come in here and take a look at this surface and see what that measurement is. The ISO 4287 R sub A, we're at about 4.57 micron for that part. So to recap, the white light confocal can make this measurement very easily. It is a lot of data, so if we did need to go faster, then we'd probably want to consider using our multi-point line sensor, which has 108 points across there. So we could collect over 324,000 points a second, and would be able to scan this, 100 times faster and get that information out if needed.